Hi everyone, thanks for joining my session. In the next 40 minutes or so, we're going to talk about networking on Azure, and we're going to specifically look at the services that Azure has to offer, the networking features it has to offer that we can use with the platform as a service offerings we all use every day. Stuff like Azure SQL, the web apps, Key Vault, things like that. So, my name is Erwin Staal. I'm an Azure architect and DevOps consultant from the Netherlands. I live in a place called Assen, and I work for a company called 4.net. And as you would probably have guessed from the name, we are a company that specializes in consultancy and training, etc. On .NET, on the Microsoft technology stack. So things like Azure, .NET, but we also do things like Angular, etc. So before we dive into the details, the specifics on the networking stuff on Azure, we should probably talk a bit about why. Why would you actually invest your time in adding networking features to your infrastructure, to your platform? The obvious reason is security. We want to make sure that the data we process and the data we save is being saved and processed in a secure way. And this diagram, which I found in the Microsoft documentation, is a nice way of explaining that. So this diagram comes from the PCI DSS compliancy standard. That's the credit card payment standard. And Microsoft has great documentation around that compliancy standard, explaining how you could be compliant with that standard on Azure. And especially with handling data as credit card data, you want to make sure that the data is processed and stored securely. So how can we do that? So security is always a matter of multiple layers of defense. And that's what you actually see in this image right here. On the right, there's the platform as a service offerings we can use to store our sensitive data. So you see things like Azure SQL and Key Vault, of course, for the passwords and the certificates, things like blob storage, etc. So those are the things we want to hide away back in our infrastructure, in our network. So as you can see, there's different layers around that secure data, and all these layers are networking layers that we can put in front of the data to make it more secure, to make it harder for the outside world, the internet, to gain access to that particular services that live deep down in the network. So we aren't going to make it as complex as the diagram you saw there, but this is what we're going to do today. This is our goal for today. So I created two applications, a front-end application, which you see over here, and I created an API, and I already created a database in Azure. So the goal for today is to make the combination, the connections between these services secure. So what we're going to do is make sure that our SQL database can only be accessed by our API and not anymore over the public internet. And we are then going to make sure that our API can only be accessed by our UI and not by any other service that might be out there. And we're going to do that by implementing a few of the pretty new services that are available on Azure. So let's start with one of the basic building blocks we're going to need to be doing any networking things on Azure. And that is obviously a virtual network. We're gonna need a place to put our applications and our Azure services in, to get a private IP address and to be able to communicate with each other. So we can create a virtual network on Azure, and as you can see in the diagram over here, we have a virtual network, and a virtual network can contain one or more subnets, which allows us to divide our services into even smaller groups if we want to. So there's a few IP ranges you can use to assign to those subnets and the virtual networks, and you can use the three well-known private IP ranges out there. So depending on your needs, you might want to pick one of these three. A thing to keep in mind is that because of as you need a few IP addresses out of your subnet, you need to keep that into account when creating a subnet. So the smallest subnet you can create is one that can contain 3 hosts and is a 29 segment based subnet or virtual network. So that is because Azure already uses 5 of the IP addresses from your subnet to do its work. So that's why the smallest you can create is the one with the 3 hosts. So you need to keep that in mind. Alright, so Alright, so let's move into the Azure portal to see how we can actually create one of these virtual networks and subnet, and how that's been done. So before we're gonna do that, I want to show you what I've already created prior to the demo, which we're going to use in this demo. So there's 2 web applications. There's an API and there's a UI, a front-end application. And I've already created a database on a SQL server that we're gonna use. And as you can see, there's already a virtual network being created, which we are later gonna use for the front-end application. So this is the actual UI. As you can see, it's very simple, and it retrieves a list of data from our API, and that API simply returns that data as a JSON list. Alright, so let's add that virtual network. You can simply do that right here and click create. So it obviously wants to have a name, so we're gonna call this one the API one. We're gonna create that in Western Europe. That is important. We will come back to that later, but because of some of the integrations we're gonna need later on, you need to create your virtual network in the same region as one of your other resources. Let's go back here. Alright, so next thing we need to do is give it an IP range to use. So it already starts with this one, but I want to have another one. We're gonna create the 10, 20, 250, 0, 0, and we're gonna make it a 24. We then need to add 1 or 2 subnets. So I'm gonna create a default subnet, which I'm gonna give a bit of a smaller range than the entire virtual network. And as you can see, it already lists here how many IP addresses are for you available to use. And that's again because of the 5 Azure reserved addresses. So you need to keep that into account creating your virtual networks and your subnets. So I'm gonna make a default one. This is the one we're later on gonna use to give an IP address to our SQL server. And I'm gonna create an additional one. That one's then gonna start at, let's start at 128. So it's the name obviously. So we need to move that into there. So this is going to be the subnet that we're later gonna use for our web app. It needs to be a different one. It cannot be the same, but we'll get to those details later on. So I gave it a address range, and I gave it 2 subnets, of which the address ranges do fit in the overall address space. So that's it. We hit review and then hit create. So then my network will be created, and most of the time that's something that's a pretty quick thing to do. As you see, it's already done, and it's ready to be used by us. So let's head back to the slides, and let's have a look at the next feature in Azure we're gonna use to build up our secure environment. So we're gonna make our way from the back of our infrastructure to the front end. So we're gonna start with securing the database, then we're gonna handle the API and the front end application. So we're gonna start with the database here. And to be able to securely access the database and to make sure that our API is the only thing that can access our database, we're gonna use something that's called a private link. And the Azure private link is a service which allows you to access a PaaS service, a platform as a service offering, over a private endpoint. So that means that you can actually give a private IP address to a key vault or give a private IP address to a SQL server, which is what we're going to do in this particular demo. One thing to note on the SQL server side there is that you're actually giving that IP address to your SQL server and not to an individual database. So that means that each database that lives on that particular SQL server is accessible over this private IP address. So that's a good thing to keep in mind. Alright, so by doing that, by adding this private link to the SQL server, for example, that SQL server no longer has a public IP address anymore. So it isn't publicly reachable anymore as you would normally do. The great benefit of this is that the traffic to and from your SQL server now remains on the Microsoft network, as where it otherwise could also go over a bit of a public network. It now stays in the Microsoft backbone network, which makes it obviously a bit more secure, but also a little bit faster and more stable. The private link also allows you to integrate with on-premises services. So if you would have an on-premise virtual machine, for example, that connects into your virtual network, you could also reach your Azure SQL database now from that virtual machine. And also works with peered networks. So if you would have a second virtual network and you would set up peering between them, a connection between them, then you can also reach your SQL server, for example, from the second virtual network by the private endpoint connection. So the private link is available on quite a lot of Azure services already. Most of them are general available. As you see in this list, few are still in a public preview, among which is the Azure Web Apps. So if you want to use it there, then please be careful, but it is still a preview feature there. And another thing to note on the Azure Web Apps is that you do need to be on the premium plan to be able to use the private link. So it doesn't work on a basic plan or a standard plan, it only works on a premium plan. So that makes it a bit of more of an expensive option because of the pricing there. Alright, so let's go back into the portal and let's see how we can add that private link to our SQL server. So we're gonna move over to our SQL server, which is right over here. And before we are going to add the actual private link, we are going to make one or two other changes to our Azure firewall. And one of the most important one is the one over here. It's the switch that now says that all the Azure services are allowed to access this server. By setting this to yes, I was able to make my API being able to connect to my database. But we no longer want that over the public addresses. We want to do that over the private one. So I'm gonna set this one to no, and I'm gonna hit save. So later on, we could also, and that's something that's actually gonna be done by adding a private endpoint. Also, this one is going to be set to yes. The deny public network access is going to be set to yes when we add the public or the private endpoint. And that will make sure that no one can access the database anymore apart from going over the private connection. Alright, let's go over here, the private endpoint connection, and let's start adding the private endpoint. So it needs to be in the right resource group. We need to give that a name. So let's name that SQL private endpoint. Again, I want to have that thing created in my region, the Western Europe region. And the next thing is that we need to pick the resource we want to create the private link for. So we're going to scroll down and find the SQL servers, and we're then going to pick the SQL Server we're gonna use today, which is this one. We're then gonna hit next to go to the configuration. You now need to pick a virtual network that you want to use. So we're gonna grab the API one, and then it lists my two subnets, and we're gonna pick the default one, since we're going to use the other one for the API later on. Alright, another thing here is the question or whether you want to create or integrate with an Azure private DNS. And the answer is by default yes, and we actually also want that. Because that will make sure that Azure creates a private DNS zone for you, which contains the DNS record of your database. So that allows you to later on still use the normal connection string like you used to connect to your database instead of that IP address. So you don't actually need to connect on that IP address. You can still use the connection string like you always do, just the DNS record, because of the integration here with the private DNS. So we're gonna keep that to yes, and the information that has been filled out here is it's perfectly fine to do so. Alright, so I'm gonna hit review and create, and let's hit create, and then the private link will be created for me. This is an operation that sometimes takes a little bit longer. So while this is being created, we're gonna hit back to the slides to have a look at the next feature, next service in Azure we're gonna use to make our demo work. Because now that we have a private link on our database, we also need to make sure that our API can actually use our virtual network to connect to the database. And that can be done by something that's called a VNet integration. And on an Azure web app, there are two types of VNet integration, and which are the regional VNet integration, which is the default, but there's also another one, a gateway VNet integration. We'll talk a bit more about the second one later on, but we're actually going to use the regional VNet integration today. So what does that do? That VNet integration allows your app servers to join a virtual network, or actually a subnet within a virtual network, and it will then use that virtual network, those IP addresses, for its outgoing traffic. So that's important to know. There's no traffic coming through your subnet into your app service. That's still going over public addresses, etc. It's just for outgoing traffic. And it then allows you to access resources in your VNet within the same region. I mentioned before that we want to create our virtual networks and the subnets in the same region as where our resources are. That is because you can only use the VNet integration, the regional VNet integration, if you are in the same region. So you need to be. It does require a standard or premium V2 app service plan to work. So no basic app service plan, that won't work. But that's okay. It's at least it's also on the standard one and not just on the premium one. So that's okay. And because we now have a VNet subnet integration, we can also use the network security groups to limit the traffic. So a network security group is kind of like a list of firewall rules, and you can now use that to block outgoing traffic. So that allows you to make sure that your API, for example, actually can only go out to your database and cannot go out to the internet or to any other service. So you can also lock down the outgoing traffic by using a network security group. All right, let's go back into the portal to our API. So we go to the API, and we're gonna find the networking tab, and then we're gonna hit this configure button under the VNet integration. So you hit add VNet, and then here's the list, drop-down list that allows you to pick a virtual network. So here you can see again the two types of integration you can do with an app server. So here's the same VNet, which I call the regional VNet integration, but there's also other regions where you can pick from. But that one requires, as it states here, the virtual network gateway configuration and the VPN connection to be actually used here. So you could do that, but the easier option is going for the same region, the regional VNet stuff. So we're gonna do that. We're gonna pick the API one, and again we then need to select a subnet for the integration. And as you can see, we can't use the default one anymore because that one we already used that one for the SQL Server. That one got an IP address from this particular range. And what actually happens here when you add the VNet, when you do the VNet integration, you're actually kind of telling the app service, like, here's a subnet, it's yours to use, do whatever you want with that. So you're actually delegating that particular subnet to the app service. So that means that you can only connect one particular app service plan with a particular subnet, and there cannot be anything else using IPs from that subnet. So it needs to be empty before you can assign it to an app. Let's hit OK, and it shouldn't take too long before you see that it's connected and that this subnet is now being used. All right, so that means that our API now has a connection with our VNet, and we should now be able to again reach our database. But before that would actually work, I had to add two settings to our app service, which I already did in advance. And those are the website DNS server and the website VNet root all. So first, the DNS one, you need to set this to this particular IP address, which is the IP address of the Azure DNS. And you need to do that because if you wouldn't do that, then the app servers wouldn't work with your private DNS zone, which we created earlier. And that would mean that if you would try to connect to your database using the DNS record, the connection string you would always use, then it wouldn't work anymore because it couldn't find that particular record anymore. So we need to specify the DNS server here, and the second one is the one over here, the website VNet root all, and that one needs to be set to 1. And what that will do is that by setting the setting, all the traffic that goes out of your web app, so all your egress, will actually go through your virtual network. If you wouldn't set this value, then only the private network connections only the private traffic would go through your VNet and not just all the traffic. And that is something we actually need here. So you also need to set this particular setting. So these two settings and their particular values are nicely documented. So if you search for web app VNet integration, then you will find a documentation page where you can find these two settings and their values. So that's quite easy to do. So if you now go back to our API, which now shows an error because I closed down the firewall. If we now refresh this particular page, we again have a working API, and also our UI now again works. So that's cool. We can also do a double check there, and we can do that by going to the console, and then we can use a particular command, which is the one over here. I'm using the name resolver tool, and this will work because I'm on a Windows app service plan. So we're using the name resolver tool to resolve this particular address, which is the address of our database. And if we do that, then we see that the address we get back is actually a private IP address that comes from our range instead of the public IP address that we would have gotten before we did the private link integration. So this is actually a nice tool, nice way to check if the configuration actually worked and if you, for example, hitting the right DNS server. So another thing we could check here is we could go back to our virtual network. So let's do that quickly. And you would actually see a connected device here. And this is, as you remember correctly, the SQL private endpoint. And that indeed now has a private IP address. The 0.4 has been assigned to my database. So that's another way how you can check if the connection is actually there and what is the IP address of that private connection. All right, let's go back to the slides. So what we've done so far is we've added a private IP address to our SQL Server, and we made sure that our API now also uses its subnet to connect to that SQL database. So SQL database has been locked down, that's good, and our API can use it. So next thing we want to do is make sure that our UI is the only resource, the only app that can actually connect to the API. And we're going to use something called a service endpoint, and later on some access restrictions to be able to do that and to lock down that traffic. So first, the service endpoint. The service endpoint looks a bit like the private link, but it's also a bit different, obviously. What it does, it provides a secure and direct connection to Azure services. So where you would normally, if you would go to a service within Azure, so from your virtual machine, for example, to a database, that would normally go over a public network, and now you get a secure and direct connection to the Azure services. So that means that traffic to the particular service remains on the Microsoft backbone network. So that's good. That's more secure, more stable, more performant. So and on the other side, by doing that, we also know that then the traffic from that virtual machine or the app service then goes through our private network coming from our subnet. We can also restrict traffic on the other side to only be allowed to come from that particular service endpoint. We're going to see that in a bit. So let's first go back to the portal and let's see how we can actually activate the service endpoint on our VNet. So to do that, we're going to the virtual network that I created for my UI for the front-end application, because that is the one we want to lock down. So we want to make sure that only traffic coming from this particular virtual network is allowed to go to the API. So that means that we have to activate a service endpoint on this subnet to make sure that this subnet, the front-end subnet, has the direct connection to our API. So if we go to the subnet page and we go to the web app one, this is the one we're later on going to use. Then you can see I already added the service endpoint for Microsoft.web. And as you can see, there's quite a few others. I already did that because it sometimes takes a while to be activated, and we don't have that time here during the demo. So the service endpoint has been activated, so that means that if we would add our app to this subnet, it would be allowed to go to another service using that service endpoint. So let's go to the front-end application and make sure that we integrate that with that particular subnet. I'm going through this one a bit quicker because we already saw the same thing actually happening on the API. So again, I'm picking a different virtual network here, picking a subnet, and there isn't any network peering or whatever enabled between the two virtual networks. So traffic is actually going through the private, through the service endpoint to the API. All right, so that's as far as we need to go for from the UI perspective, from the front-end application. Now, to make sure that our front-end is the only thing that can access our API, we need to restrict traffic to just be allowed from this particular subnet we used over here. So we're going to go back to the slides real quick, and I'm going to show you what type of service we can use to do that. So to lock down our API, our web app, to just allow traffic from a particular subnet, we're going to use something called the access restrictions. And that allows you to define a list, an ordered allow deny list, that controls what is allowed to access your app and what is not. And you can do that by specifying IP addresses or pointing to particular virtual network subnets and say that traffic from those is allowed or is not allowed. So that's what we need here. So let's go and configure that in the portal. So we're going back to the API, which is right over here. We're going back to the networking tab. and we're going to find the access restriction configuration page, which is right over here. So by default, there's just one rule, and that's the allow all rule. So that means that wherever the traffic is coming from, it's allowed to access our application. So we're going to add a rule to change that. We're going to add a rule for the UI. We will allow that. You can provide it with a priority so that you can make an ordered list of stuff that is allowed or not allowed. And then you get to pick the type of traffic you wanna allow or deny. So you can pick the IP4 or IP6, or what we want to do here today is we want to pick a virtual network. So it allows you to pick a particular network, which is in our case the UI one, and we want to allow traffic coming from this particular subnet. So let's add it. Takes a little while. So now that has been added, what also gets added by default for you then is now a deny all rule. So that means that this one is allowed, so traffic coming from a particular subnet is allowed, but any other traffic is now being denied. So that means that if I now try to refresh this particular page, I'm getting a forbidden page because I am no longer allowed from my home IP address to connect to this particular application. But if I would refresh my front-end application, then you see that I still get the expected result because this application now is allowed to go to the API. So that's pretty cool. That all works. So there is a second list of second allow deny list right here, and that's the one that's being used for the management API management side of things for your Azure app service. So if you would, for example, deploy your application, then that management plane is being used. If you, for example, go to use Kudo, the management console, then the management plane is being used. So you can also add IP addresses or VNets, whatever, to this list to deny access to the management plane. And actually a good idea, of course, to lock that down as well. What you do need to be aware of here, and it's not just on an app service, but basically any service on Azure you lock down, is that you only allow it access from a particular subnet. So that means that if you want to deploy your web app to your app service, or if you want to do a database migration from within your release pipeline in Azure DevOps, that suddenly those Azure DevOps agents that perform that action for you aren't allowed anymore to have access to your application because you denied that on a network level. So the only thing you can actually do today to work around that issue is to create your own release agents within Azure DevOps. So that means that you have to create a virtual machine and use that virtual machine as a release agent in Azure DevOps, because then you could put that virtual machine in a virtual network and allow that virtual network here in this list to be allowed to deploy your application and to access the management plane. That sounds a bit harder than it actually is, because all of the stuff you need to do that, all of the stuff you need to create your virtual machine, you can actually find that on GitHub. The whole definition of the Azure DevOps build agents and also the GitHub action agents for that matter, all of the stuff you need to build those is open sourced on GitHub. It's just a few commands to build your own VM image and to create your virtual machine from those images. But it's something you need to be aware of, that if you start locking down your resources, you also need to think about how am I going to access those resources to do my management work. All right. So that being said, let's go back to the slides again. Because we're gonna talk a bit further about accessing your resources from more of a management perspective. Because obviously if you lock down your services into VNets, etc., you still want to be able to access those to do some management, or maybe create a backup of your server and store it elsewhere or whatever. So one of the ways you can do that is to add some way of VPN connection to your virtual network, so you're able to securely connect to your subnet or your virtual network using a VPN connection. So there's a few different options in Azure you can pick from, depending on your needs. We're gonna go through the list of them to see the options here. So the first option you have is the site-to-site or multi-site connection, which is basically a VPN connection between your office location and a VPN gateway within Azure. And that VPN gateway is a service in Azure that can be used to send encrypted traffic between your Azure network and your on-premise location, or between different Azure networks around the globe. So in this particular example, it's been used to send traffic between your on-premise location and a VPN gateway, a VPN, and your subnet. So this is an example of a multi-site connection. You can also do that if you have multiple offices around the world. You could use a multi-site connection to connect into a particular virtual network and get secure access. We can also do a VNet to VNet connection, so we can build a VPN tunnel to do that. If you want to have a VPN connection between different Azure data centers. So if you aren't in the same region but still want to have a secure connection and be able to have private connection there, you need a VPN to VPN connection. You could also add an express route connection, so that could be a backup solution, or that could also be your primary solution, because an express route could give you a bit of more performance secure connection into Azure. So that's also an option. And probably the easiest option to at least get started with and to try a few things out is a point-to-site VPN connection. And in a point-to-site VPN connection, we don't have any dedicated hardware in our offices or whatever to create that connection for us. It's the clients themselves who have a bit of software on their machines, their devices, to make the connection into the Azure VPN Gateway. So it's not just one connection anymore then, but it's just every client gets a dedicated VPN connection into the Azure VPN Gateway. And there's a few ways we can authenticate and secure the connection. You could use a certificate to do that. You could use the Azure Active Directory. Radius is a protocol that can be used here, and there's also the OpenVPN standard that you could use to encrypt and secure the connection. Right, so there's also the option to go for a third-party supplier to get this done for you. And in one of my clients, we used a solution from Cato Networks. And there's a few benefits you get from going for a third-party solution instead of the built-in Azure ones. And so for Cato, for example, the thing is that they have nearly 50 locations in the world where your clients will connect to, and then once they are connected with the Cato network, they will go through a private backbone connection into the Azure network. So that means you have a faster, more reliable, and more secure connection into Azure compared to what you would have if you would have a direct VPN connection into Azure. What's also a benefit of a solution like this is that you could also get private IP addresses assigned to each VPN connection. So that means that you can also use those IP addresses to do whitelisting on different services. So you could use those IP addresses from your VPN connection to do whitelisting on a SQL database, for example. But you could also use that to do whitelisting on different services. For example, you can do whitelisting on GitHub these days. So that would make sure that only your employees using the VPN connection can actually access your repositories on GitHub. So that's a cool feature. Another thing we got by using the Cato is that whenever someone connects into Azure, that traffic actually goes through something we call a next generation firewall. And that firewall will obviously make sure that that connection is safe, but also that we can't send any malicious data into our Azure tenant. So the data we send across the line is also being scanned for any malicious content what might be in there. It also gives us a nice dashboard which allows us to see the connected clients, the traffic going through, what the particular traffic is, how much traffic is there, and allows you to set the firewalls and whatever. That's it. That's what I want to talk to you about today. Thanks for attending my session. If you have any questions, you're always welcome to reach out to me via LinkedIn or via the Twitter handle you see on the screen right here. You can also go to my blog, which is erwinstaal.nl. I occasionally write there about stuff that I do in my daily job, mostly about Azure and .NET, obviously. So thank you, and see you next time.